Welcome to my channel. In this video, we will be discussing about Bernoulli's theorem. What is the Bernoulli theorem and how does it works? What are the equations and how it is useful in practical life? So basically, Bernoulli theorem says that the total energy of a moving fluid comprising of gravitational potential energy, fluid pressure energy, and kinetic energy of fluid motion remains constant along a streamline. That is the total energy comprising of potential energy plus kinetic energy and fluid and the pressure energy of fluid will remain constant along a streamline. So if we consider this pipe and there is a streamline, and along this we are considering number of points. Say suppose this is point 1 where the velocity is v1, pressure is p1 and area is a1, and along this same streamline we are considering another point where the area of pipe is a2, pressure is p2 and velocity is v2. Then we have that potential energy, first of all pressure energy, that is p1, plus kinetic energy, that is half rho v1 square, plus the potential energy due to location of this fluid, these fluid particles, that is rho g h1, will be constant and will be equal to the sum of potential energy, that is rho g h2, plus kinetic energy half rho v square, plus pressure energy at point 2. So along a streamline, total energy will remain constant. And this is the basic equation of the Bernoulli theorem. And if we divide this equation throughout by rho g, that is the density of fluid, then we will have p1 by rho g. So that will be p by rho g, and half rho v1 square by rho g. Then rho will cancel and we will be left with half v square by 2g. This half v square by 2g is also known as the velocity head, plus rho g h1 by rho g. Rho g will cancel out and we will have h. So this will be constant. Basically, the potential energy, that is rho g h1, is depending upon the location of fluid particle from the datum. That if we assume this as datum, then what is the location of the fluid particle or streamline with respect to this datum? If the pipe is entirely horizontal, there is no change in elevation, then h1 will be equal to h2, and we can say that h1 and h2 will cancel out, and we will have the sum of pressure energy, that is p by rho g, and half v square by 2g, half v square by g, will be constant, and this term, that is due to potential energy, will cancel out from either side. So in this way, we can say that the total potential energy will cancel out, and we have that pressure energy plus kinetic energy is equal to constant along a streamline. So what do we mean by that? That if the pressure energy is decreasing, then kinetic energy will have to increase to balance it. The sum of pressure energy and kinetic energy will remain constant along a horizontal pipe, and for that purpose, if the pressure energy is decreasing, then kinetic energy has to increase, and if the kinetic energy is increasing, the pressure energy has to decrease. So in this way, these two balance out each other. Similar to, suppose we have a 100 rupees in terms of 10 rupee notes and 20 rupee notes. If we have, suppose, four 10 rupee notes, then we have to have three 20 rupees notes for balancing it out. And if we have two 20 rupees note, then we need to have six 10 rupees note. So if the number of notes of 20 rupees are decreasing, then we have to increase the number of notes of 10 rupees to maintain a constant or total of 100 rupees. And if the number of 10 rupee notes are decreasing, we have to increase the number of 20 rupee notes to balance the amount of 100 rupees. Similarly, if the pressure energy will decrease, then kinetic energy will have to increase to balance it out. And if the pressure energy is decreasing, then kinetic energy will have to increase. So in this way, this Bernoulli theorem, helps us to find the pressure energy and kinetic energy at different locations. This is the setup which we use for performing the Bernoulli theorem experiment. Here we have a sump from where water is transferred to the overhead tank, and from this overhead tank a venturi meter is attached in which the flow take place. And to measure the pressure head at different locations of this venturi meter, we have piezometers connected to it. And finally, after the water passes through this venturi meter, we have an arrangement of collecting tank where we measure the volume of water collected in due duration of time to calculate the discharge. This discharge will be required to calculate the velocity head. So in this way, we will measure the pressure head from the piezometers and velocity head using this collecting tank by measuring the volume per unit time, that is the discharge, and then dividing the discharge with area to get the velocity head. So this is the piezometer here. Initially the diameter is constant, then it gradually decreases to throat, which is the area of minimum, which is the location of minimum area. Then again it starts to increase, and it reaches a final constant diameter. So this type of pipe is known as venturimeter, where we gradually decrease the area and then increase the area to obtain certain characteristics of flow. In at each location, this venturimeter is connected through piezometers. Here it is shown. The piezometers are connected to the venturimeter, and from this these piezometer at different location we will get the pressure head, which can be read from these scales, which are behind the piezometers, and we can easily measure the pressure head. So when the flow takes place, first we measure the pressure head at each in each of the piezometers, and then we have this arrangement to measure the discharge of the discharge of fluid flowing through this venturimeter. For this, we have an arrangement of piezometer again connected here. We take the initial reading at which we start noting the time, and for a 10 centimeter rise, we will note the time taken to for 10 centimeter rise. This may be repeated 2 or 3 times to get the average discharge. And this increase in height of water, that 10 centimeter rise of water takes time t. Then we have the area of collecting tank area, this is capital A, the area of collecting tank. Then we multiply it by area of collecting tank to obtain the volume of water collected in time t. And when we divide this area into height is the volume divided by times gives the discharge. And to calculate the velocity at different location, we have a small area A. Here it is capital A, it is actually small a. At different locations we know the diameter, so we can measure the velocity at different locations. So suppose this is the first piezometer or first location where we have to measure the velocity, then we have v1 will be equal to q upon pi by 4 d1 square. This is the location 2, then we have pi by 4, v2 is equal to q upon pi by 4 d2 square. In this way we can measure the velocity at different locations. And once we know the velocity, then we can easily calculate the velocity head, that is in this form: v1 square by 2g, v2 square by 2g, v3 square by 2g, and so on. And similarly, we have measured the heads in piezometer that represent p by rho g, p1 by rho g, p2 by rho g. In this way we can have the pressure head. So obtaining these two things, pressure head and velocity head, since the pipe is horizontal, venturimeter is horizontal, we need not to bother about the gravitational head. or the datum is same, so they will cancel out, and we will after calculating these two things, we will find that the wherever the pressure head is increasing, the velocity head is decreasing, and where the velocity head is increasing, pressure head is decreasing. And overall both of them, when we take the sum of pressure head and the velocity head, that will be constant throughout the venturimeter. In this way we can perform this experiment, and based on this Bernoulli theorem, we have very large number of applications in practical life. Some of them I will discuss, and others there are multiple applications where we can use the Bernoulli theorem. Basically, the increase in pressure head or the decrease in pressure head is governed by the velocity head. So if we are standing at a platform and a train is coming, so it is generally said that remain away from the platform, some maintain some distance from the train, because what happens when the train rushes into the station or platform, it will increase the velocity of air present at this location near this train, and the increase in velocity will be followed by decrease in pressure, because total pressure energy and velocity or the kinetic energy remains constant, so pressure will decrease, and due to this decrease in pressure, suction will develop and you will be sucked towards the train. So it is said that remain maintain a constant a distance from this coming train incoming train. Similarly, in the case of spray, what happens? This is the spray. We blow the air through it, and due to this blowing of air, what happens? This area will have with a great velocity. The air will move from here, and this will create low pressure air and high pressure on the downward side. So the liquid will be sucked toward this high pressure and low pressure area, and the wind or air coming from behind with great velocity will move this water or liquid outside. So this is the working principle of sprays. This is also based on the Bernoulli theorem. Similarly, you have seen that when there is wind is strong winds are blowing, the roofs gets lifted up. They don't move in horizontal direction, rather they get lifted up. This is also due to the Bernoulli theorem, because initially the pressure above the roof and inside the room are almost constant, so they are balanced, are almost in balance with each other. But when the wind start blowing in a very with very high velocity above the roof, the pressure above the roof will decrease, and inside pressure gets higher. So the winds move from or the air moves from high pressure region towards low pressure region. In this way, the roof gets lifted up and blown away with the pressure. So these are some applications of Bernoulli theorem. More applications are available, and there are a lot of applications which cannot be discussed in short video. Thank you for watching my video. Please subscribe to the channel, like and share the video.